Alright guys, so this is the foldable that goes over the volume and surface area of pyramids and cones. So first of all, a pyramid, to define it, it is a polyhedron with, now we have only one base. Remember prisms, we have two, and one vertex. Okay, and the bases and the vertex are always going to be at opposite ends. And then I can say the lateral faces are triangles, and I'm just going to put a triangle here with a common vertex. Okay, so when I say vertex, that means this point right here. And once again, usually we see these with the vertex at the top, but it doesn't necessarily always have to be. All right, so kind of like before, this is our base down here. And then we have, because we have a pyramid, we have three lateral faces. So here's one, here's two, and then there's three. All right, so the slant height, guys, this is very different than the height. It is the height of the lateral face. Okay, so think of all these triangles or lateral faces, the slant height. Let's see if I can draw it. So this straight up and down here, guys, that's the height or the altitude. Okay, the slant height is this right here. Sorry, that's not very straight. But it's the slant, literally the slanted height. So those lateral faces go at a slant. It's the distance of one of those. Okay, the base edge is just the segment connecting the base of the vertices. Let me rewrite that. Segment connecting the vertices of the base sounds better. This is why I'm a math teacher and not an English teacher. There, that sounds a lot better. So it connects here to here. That would be a base edge. Here to here, that would be a base edge, and here to here, that would be a base edge, because this whole thing is the base. Okay, the altitude, think of the altitude as the height. Let me get a different color here. And it is the perpendicular, and I'm just going to put this symbol for it, distance between the base and the vertex. So my altitude is right here. And just think of that, we call that our height. All right, guys, you don't have this in your foldable, but it might be a good idea to make note of it. When we name pyramids, kind of like when we name prisms, we name them according to their base. Okay, so like this one here in yellow, it has a square base, and so we call it a square pyramid. This one in green, it has a triangular base, so we call it a triangular pyramid. Here, it has a pentagon as a base, so pentagonal pyramid, and then hexagonal pyramid. Okay, so it goes on and on and on, but we name it according to its base. So the volume of a pyramid is pretty similar to the volume of a prism. There is one exception. Okay, so the volume of a pyramid is 1/3 area of the base times height. Okay, so B is the area of the base, and H is the altitude or height. Okay, so the area of the base will be different, a different formula depending on what shape the base is. So if it's a triangle, it'd be 1/2 base times height. If it's a Square, it'd be side length times side length. If it's a regular pentagon, it'd be 1/2 apothem times perimeter. Okay, so depending on the base, the formula we use for this big B right here is going to be different. Okay. Now, if we go into a cone, the volume of a cone, okay, well, the cone is just basically a pyramid with a circular base. So the volume is just going to be 1/3. We know the base is always going to be pi r squared times h. Okay, so all we did is substituted pi r squared in for the area of our base. All right, let's look at this first example here. We want to find the volume of this pyramid. Okay, well, I notice my height is 6. Okay, so my volume of a pyramid is 1/3 area of the base times height. Okay, well, the area of the base, guys, here's my base. Okay, and I'm going to go ahead and it has 1, 2, 3, 4, 5, 6. It's a hexagon. Okay, so the area of a regular hexagon, and I know it's regular because I have all these tick marks that show me the sides are the same, and all these angle arcs that show me the angles are the same. So the area of the hexagon, I'm going to put in here base, equals 1/2 times apothem times perimeter. Okay, well, the apothem is given to us, guys, right? The apothem is right here. 2 square root of 3. And the perimeter, if every side is 4 and they're all the same, is 4 times 6, because there's 6 sides. So this 2 and this 2 go away. So it's just square root of 3 times 24, or 24 square root of 3. Okay, that's the area of the base. So I'm going to take this and I'm going to plug it in right there. Okay, so the volume equals 1/3. The area of the base is 24 square root of 3. And my height, I've already identified, is 6. Okay, well, if I simplify that, I'd get 48 square root of 3, and that's centimeters cubed. Or if I want to round, that's roughly 83.14 centimeters cubed. And that's my answer. All right, so here I have a cylinder. And I wrote down the cylinder formula here, so we're going to use it. Cylinder, the volume is 1/3 area of the base times height, which is pi r squared times h. Okay. I have my radius is 3. My height is 7, so if I plug it in, volume equals 1/3 pi r squared, so 3 squared, times h, which is 7. So 1/3 pi, 3 squared is 9, times 7. So 9 over 3 becomes 3. 3 times 7 is 21, so this is just 21 pi centimeters cubed. That would be exact. If I want rounded, if I plug that in my calculator, I get 65.97 centimeters cubed, roughly. And that's my answer. All right, so let's go over the surface area of pyramids and cones. Okay, so once again, we're going to separate this into the area of the base, and then we're going to add it to the area of the lateral base, or the lateral faces. Okay, so here the area of the base is in yellow, and then the lateral faces is all the rest of this, right? This on the front of it, everything. All right, so the lateral area only, so without the base, is lateral area is 1/2 times the perimeter of the base times the slant height. So the P is perimeter of the base. The L is our slant height. Okay, and I'm going to put in here which is not equal to the height. Right, so my slant height would be like this right here. This would be my slant height. Okay, so if that's my lateral area, my total surface area is going to be the area of the base, and we only have one base, plus my lateral area. Okay, so plus whatever I get up here. Okay, now cylinder is a little bit easier. Because my lateral area is still 1/2 perimeter times slant height. So 1/2 my perimeter then, think of circle. So all the way around the circle is just the circumference. So 1/2 times 2 pi r, that's my circumference, times my slant height. They have this as S. This is usually designated with a capital L or a lowercase l in cursive. Well, guys, that makes it easy because my 1/2 and my 2 cancel out. So my lateral area is just pi r l. Okay, and if that's my lateral area, my total surface area is going to be the area of the base, so pi r squared, plus my lateral area, which is pi r l. All right. So let's look at this example. It says find the total surface area of the pyramid. Okay, well the surface area of a pyramid is the area of the base plus the lateral area, which is 1/2 perimeter of the base times slant height. Okay, well it gives me the slant height is 7. The perimeter of the base. Well, let's check out this base. Okay, so here's our base. So if I draw this over here, this is 3, 4, right angle there. Okay. So I can already find the area of the base. So area of the base equals 1/2 3 times 4, which is 6. So the area of the base is 6. So 6 goes in right there. Okay, I need the perimeter of the base though. Okay, so in order to find the perimeter of the, I have to find right here. Okay, well notice this is a right triangle, so I can just use Pythagorean theorem. 3 squared plus 4 squared equals, I don't know, hypotenuse squared. So 9 plus 16 equals c squared. 25 equals c squared. To undo a square, you square root it. So my c is 5. So my perimeter is 3 plus 4 plus 5, which is what, 12? Okay, so my perimeter is 12. Now it's just a matter of putting it in there. So surface area equals the area of the base is 6 plus 1/2. My perimeter is 12. My slant height is 7. All right, so that is 6 plus, well, 12 over 2 is 6. 6 times 7 is 42. 6 plus 42 is 48, and we are talking about area, or surface area, so that would be centimeters squared. I want you to go ahead and try this one on your own, and then we'll go over it. All right, so if you went and did this correctly, you should have gotten 504. So the area of the base, it's a rectangle, so it's just 12 times 12, which is 144. So that goes in right here in the purple. Plus 1/2 perimeter of the base times slant height. Well, guys, the slant height's given. It's 15. And the perimeter, it's just 12 all the way around, so 12 times 4 is 48. When you plug that in and do a little bit of math, you should get roughly 504 centimeters squared.